Hello everyone, in our series of experiments on computer graphics. Today I'm presenting our first part of the third experiment, in which I will be telling you about line clipping algorithms. To do the implementation, we'll be working on the Cohen-Sutherland algorithm. So we'll be given with a clipping area as seen in this diagram, and we'll be given with a line, the endpoints of a line, and we have to judge whether the line is to be accepted or it should be partially accepted or completely rejected by the clipping area. In the Cohen-Sutherland algorithm, the different regions of the working area are denoted by some of the codes. These are coded as 4-bit binary numbers. As you can see, the inside region is given the value 0, left is given the value 1, the top is given the value 8, the right is given the value 2, and the bottom region is given the value 2. The bottom region is given the value 4, and accordingly the corners are given with the help of combinations. Like if it's top left, then we'll have to set the bits for the top and left regions together and term it as top left, and it is coded, for example in this example it is coded as 1001. That's how the top left will be coded, and accordingly other corners are also, or other corner regions are also coded. So uh, okay, now coming to the implementation part. As you can see, I have already given the values to the different regions. These variables inside left, right, bottom, and top they represent the values according to different regions in our area. And I've defined some values which can be used as boundaries for our clipping area as x max, y max, x minimum, and y minimum. These are used to define the coordinates of the endpoints of our clipping area, which is a rectangular in shape. Coming to bottom, we are having a compute code function which actually used to calculate the code for a given region. For example, we are given a coordinate x and y. This function is used to calculate the code which should be assigned to that particular region. How it works: initially it initializes as the value having inside, which is 0. So initially the code will be 0, and after that, according to our x and y coordinate, it will set the bits accordingly. So if it finds that the x coordinate is less than the minimum x boundary of our clipping area, then uh, it will just set the bit which should be done for this left region. And accordingly, if it finds that the point is above, outside those boundaries, and it will just set the bits. For example, if the given point completely lies in the top region, then it will make sure that the rightmost bit is getting assigned to 1, and if it's at the corners, then it will have to set 2 bits. For example, if it starts with a 0, which is for inside region, and it finds that the x coordinate is less than the x minimum, so it will have to set the rightmost bit to 1. And to do that, it will it will actually go through a bitwise OR operation. Like as we see in this very first if condition, the x coordinate is less than the minimum x, and it goes through a bitwise OR condition. The output of this bitwise OR makes sure that the output value, the code, is 001. So this represents that the required point is at the left, is at the left side of the clipper boundaries. After that, as the below else if conditions comes, it will check whether if it's on the top left corner. It has already checked for the point to be on the left side of the clipping area, but if it's in the top left, it will check for this else if condition where we are written y is greater than y max. It will tell that the point is lying above the top boundary, and accordingly the another bit will be set using the bitwise OR operation. So the code we got from the above if condition was 0001. Now applying the bitwise OR with 1000, which is the code for top region, we get a new code which is 1001, which actually represents top left region. So it has taken care of two conditions and given us a final code which represents the region in which the point lies. After, we should first go to the main program here. You see, we are taking input as the x and y coordinates of the endpoints, and then we are just supplying it to the cohen sutherland clip function. This function actually implements the cohen sutherland algorithm. And we have, if you are familiar with graphics programming, we have drawn the boundaries of the clipping area in a rectangular shape using the rectangle function, in which we just take care of the top left and bottom right coordinates, and this function actually draws that clipping area for us. We will show you the output and you can actually see how it actually works. So first of all, before getting to the output, we should understand how this cohen sutherland function actually works. It takes as input the endpoints of the given line as x1, y1 and x2, y2. First of all, it assigns the code to both the endpoints using the compute code function I have defined above, and we just initialize a bool variable except as false. In this while loop, if it finds that both the code for the endpoints are 0, then it understands that both the points are within this clipping area, and it understands that does not need to make any changes, and it can actually accept the whole of the line, and it puts the accept value as true, which was our bool value, and breaks out of the loop. And after breaking out of the loop, it just prints that it can accept the whole of the line. If that's not the case, if the case is that both of the points are lying outside this clipping area, maybe somewhere here and here, then it makes sure that it rejects both the points, like it rejects the complete line because both the points are lying outside, or in other case they are lying outside in the same region. This is the case we are referring to. If they lie outside in the same region or completely outside of the clipping area, for example, one point is in 1001 region and another point is in 0001 region. If we do a, here is the case where if both endpoints are outside the rectangle area or outside the rectangle in the same region, if we do a bitwise AND here, we will end up with a finite value, and because of this finite value, this else if condition will be true, and there's nothing in this in these brackets. It will just break out of the loop. It will understand that it doesn't have to accept any values, accept any endpoints of the given line, because both of the points are outside. In the other case where the 2 points are lying in such that one point is 1001 region, that is the top left, and another point is in the bottom region of the clipping area, which is 0100. So if you draw a line through these regions, we will see that some part of the line will actually be partially inside the clipping area. So it has to accept some part which is intersecting with the clipping area. In that case, if you take a bitwise AND, the output coming will be 0. So because of the 0 output, this else if condition will not be executed, and it will go to the below else condition, where we have to actually check other conditions. So as I was saying that we have to take care of the other conditions here in the below else brackets. So this is the case where some partial part of the line is coming within the clipping area. This diagram will make it more clear for you. Like if we are having these cases where the line is partially inside the clipping area, we have to accept some part of the line, including the intersection points within the clipping area. In the other cases where the line lies completely outside or completely inside, we have already taken care of that. If it's completely inside, the code for both the endpoints are 0, and for if it is completely outside, then we take bitwise bitwise and bitwise OR of it, and the output actually mm, determines whether we have to accept the line or not. As we have explained earlier, like if the bitwise AND is giving a finite value, then we have to go through this else if condition and break out of the loop, which will mean that we have to reject the line completely. So the bitwise AND, I'm saying again, is what helps us to determine whether the line is completely outside or not. Okay, if it's 0, then it means the line is partially inside the clipping area. And now we'll try to understand what to do in those cases. So we will just define a variable which is code out. So first of all, we are assuming that one of the line's endpoint is within the clipping area, other one is outside. So for one of the points which is outside, the code will not be 0, and for the other one it will be 0. So for taking the case where it is not 0, to store that variable, to store that code, we are assigning a variable code out, and for the other one we know that it is 0, and we have defined some other variables x and y, which will be of our use in further references. So first of all, it checks which of the code of the for the 2 points is 0, and whichever one is not 0, it assigns it to this variable code out, and then we do a further execution. And first of all, now it has stored the code for one of the points which is outside the clipping area, and now it checks the position of the point to just get the intersection point, because if the point is outside the clipping area, then it will surely have some intersection point, and the other point which is inside, we have to make sure that the line to be accepted is from the inside point to the intersection point, and the outside part of the line is not to be accepted. So it will do a bitwise AND to determine the coordinates. So if the given code, when we take a bitwise and it will help us to determine the position. I will tell you how. Assume that 1001 is the code for the line with the code for the point of the line which is outside the clipping area, and it is near some edge. For example, if it is near the top edge of the clipping area, the top edge has code 100, and if we go bitwise and we are getting some finite value, then this if condition will be executed, and this is the formula to get the coordinates. Like the y coordinate will obviously the maximum value of y for the clipping area, and the x coordinate will be calculated like this. So these two values are actually the intersection point for the given line and that edge which is near, which actually intersects with the given line. Accordingly, in a similar manner, it will check for whether the line is intersecting with the bottom, with the right or left. How it will check? When we execute this bitwise and we get some finite value, like we have been doing earlier as well, it will help us know that the line is actually intersecting with that edge. Okay, now we have already got to our intersection points, and earlier we assigned the code out value to one of the points code which was outside and which was not 0. Now what we will do, we will just take the value which is in code out, and for that value we will first of all we will just take x1 y1 as the new intersection new points as the intersection point of the given line and the given edge which is intersecting with the line. And now we will compute the new code 1 using the x1 y1, I mean the intersection point, which will give us a code, and we already have a code for a point which is inside the clipping boundaries. So we will have two codes, one for the point which is inside this clipping area, and another point, this one's inside the clipping area, and this is the intersection point which we got, and we assigned it to x1 y1 in this step, and we got a new code using the compute code function I've explained earlier. So now we have the two codes for this point which is inside and this point which is intersecting. This is the portion of the line which we have to accept. So finally we have got the two codes, we have got the coordinates for them. So you will wonder how we got the two coordinates. So in this if and else conditions, when it's the code out is equal to code 1, the x1 y1 variables store the intersection points. Otherwise the x2 y2 variables store the intersection points if the code out value is equal to code 2 in that case. And the other values, the corresponding other values, if x1 y1 have the intersection point, then x2 y2 will store the value which was inside the clipping region, because we never made any change to that. So we can just print the values of the coordinates and tell that the line is accepted from that region. Now talking about this accept variable, how does this thing works? If you take a look in this if else conditions, when we execute the compute code in this if and else conditions, the new code is actually 0, because the intersection point itself will lie within the clipping area. So it will make sure that the code for it is also 0, and the point which is inside the other point which is already inside the region, it already has a code 0, and the intersection point has the code 0, and we are actually running a while loop which is infinitely running. So when it will come back from the bottom where we have the intersection points and we have calculated the code for the intersection point, it will go up and check this very first condition, where we will end up having both the codes as 0, one for the intersection point and another one for the point which is already inside. And this very first if condition will be executed, the accept value will be true after the whole execution, and once it will break and when it will come to this if conditions, the accept value will be true, and we will just accept the line between the intersection point and the point which is inside. In the previous case which we talked, where the both points were inside, we'll already have a value 0 for the both codes, so it will break out of the loop at the very first if condition, and in that case the whole of the line will be accepted, which will be inside the clipping region. Otherwise if in this else if condition, the second else if condition which comes after this very first if condition, where we having the both of the points outside the clipping area in the same region or just outside, and having no partial part within the clipping region, we will just break out of the loop and we will never set this accept value as true. It will always be false. So we will end up in a situation where this else condition will be executed instead of this if condition, and the output will be showing that the line is rejected. So that's what we were actually supposed to do. Now we will take a look at different cases and different outputs that we got. This diagram actually shows the clipping region which we have to work with. This was drawn using this rectangle function. If you are familiar with graphics.h, you will know how this thing works. And now this is our command prompt where we entered the coordinates of the points. I took 50, 50 and 100, 100 to do the first test case, and as you can see, we are drawing the line using the line function here. You can see that this is the function we are using to draw the line, and from the diagram it's pretty much clear that the whole line outside is lying outside the clipping area. So the output that should be shown is line rejected. This is what we are getting. In another case, I took the points as 100, 100 and 250, 250. So if you look at the diagram, some part of the line lies inside the clipping area and some part is outside. So it will calculate the intersection point and the point which is within the clipping area, and it will show the line is accepted from this point to this point. In another case, I took the coordinates intentionally such that both of the points are within the clipping area. As you can see from the diagram, the line completely lies within the clipping area, and it will just show that line accepted from point P1 and P2. So in this case, the whole of the line is accepted by the clipper. So I think that's pretty much it. I hope you enjoyed the video. Thank you.